Okay, so I think we're ready to start. Okay, if there's an issue with the audio, just let me know. Okay, sorry about that. Okay. I'm just gonna need 1 minute because I want to record this session. So I'm just gonna take 1 minute to press record and then we'll start with a recap from last week. So in the meantime, you can just open up the work that we did last week. Okay. Okay, so today will be almost the conclusion of the redox reactions. As you can see, the section is not too long. It's just mostly a bit of rules that you have to know. And thereafter is just some terms. And you're pretty much okay with answering the exam type questions. So what we're going to do first is we are going to just look at the basic rules of when you open your exam paper. Most likely this is the last question. When you get to that question, let me just see if I have one to show you what it would look like. I don't think I downloaded a whole paper. Okay, I'll find one when we're busy with the question. But essentially, you'll get to a question in an exam paper, and the first thing you'll see is a reaction. Okay, so they'll have the whole question and they'll have some reaction taking place. And then they'll have a few questions on this reaction. So, whenever you get to this, the first thing we want to do is we need to know how to analyze any given chemical equation on the question. So I'm going to go through some basic rules that you're going to apply for any of the redox questions. And then by doing these basic rules, you sort of set the question up nicely for yourself so that when even before you look at the questions, you're able to answer the questions of which is the oxidation reaction, which is reduction, your oxidizing, reducing agent. You're able to write down your half reactions and so forth. Okay, so let's look at it. Some basic general ideas when you get this redox reaction in your paper. The first thing you always want to do before even reading any question is you want to find the oxidation number of each element in the reaction. So oxidation number of each element or substance in the given equation. Okay, so if you're looking at an example, for instance, the one I just erased, like this. So let's say this is in your paper. The first thing you want to do is you want to go to each of these elements. Remember, an element is magnesium here and oxygen here, elements from your periodic table. So each individual pure element. And what you want to do for yourself is you're going to write down what is its oxidation number above it. So use a different color, use a pencil. Most likely, I think the best is to use a pencil and write down the oxidation numbers above it from the rules that we did in the first few lessons. Okay, so once you have your oxidation number, the second thing you're going to do is you're going to look at how that oxidation number is changing. Okay, so you're going to look at how is the oxidation number changing. Most likely you're going to look from your reactants all the way to your products. And you can write notes for yourself on your question sheet in pencil. For instance, we looked at that question now, magnesium. How is its number changing? Is that oxidation number increasing or decreasing? And then once you've done that, you know you always have to get So you must always have this case. You must always have one of the substance undergoing oxidation and the other substance must be undergoing reduction. So you have to identify for yourself which is your oxidation reaction. So let's say 2.1. Let's say that there's an increase in your oxidation number. Okay, and we know if we've got an increase in your oxidation number, this is the same thing as a loss of electrons. These things now must be more and more familiar so that you know it off. So if you're looking at the word oxidation, you automatically know loss, okay, that O of electrons. Okay, so if we have a loss of electrons, oxidation reaction, we said so we know that this is obviously going to be a oxidation reaction. Okay, so we have identified the reaction undergoing oxidation, and then 2.2, we know that there's a decrease in oxidation number. This implies that there's a gain of electrons, and this would mean reduction. So this is your reduction reaction. This you have to know off by heart by now, okay? Don't leave this for the night before, the week before of your exam to learn this, because it might get confusing and you don't want to chance that. So always learn this now. So now that we've identified the two most important things, which is which reaction is our oxidation, which is our reduction reaction, we can now go on to identify something else, number 3, and that is we can say which is our reducing agent and oxidizing agent. Okay, I told you last week that whichever substance is undergoing oxidation, then that substance automatically becomes the opposite. It becomes the reducing agent. If the substance is undergoing reduction, that substance becomes the oxidizing agent. Okay, so let's write that down in a note. So we can say that the substance undergoing oxidation, this we refer to as the reduction agent or reducing agent. And then likewise, substance undergoing reduction, this is referred to as the oxidizing agent. Okay, so this is going to be your most basic set of rules when you learn the section for redox reactions, okay? So apart from knowing how to do those little things like the rules for oxidation number, this is going to be the most basic thing you need to know how to do in any of the question given to you. Okay, so assuming that this we know well and start learning this off now early, the next thing we need to know how to do is the half reactions. So last week we started talking about it. Let's just look at it. Okay, so if you look here, we did a question after here, the magnesium and oxygen example. So we did one example where we looked at the oxidation reaction, the reduction reaction, and then we looked at the basic rules here on the side of how we write the half reaction. So today we're going to do the same thing. We're just gonna, I'm going to give you the rules in a more simplified way to learn them off. And then we'll just do examples for half reactions. We'll see how far we get. And then we'll try and practice maybe some exam questions. Okay, so the first rule with a half reaction, so I'm just going to write some general rules first and then we'll start doing examples. The first thing is whenever you write down a half reaction, you always want to show your oxidation number at the top of the substance. So I'm just going to write number like this for short. That's the oxidation number at the top of the element. And the only exception where you will not write it is if the oxidation number is zero. So you will only not show this if the number is zero. Okay, so that's your first rule when you're doing a half reaction. The next important thing is you always want to show how many electrons are gained or lost. So we know we've looked at that previous example. I'm sure you're doing this at school as well. But when we write electrons, we show it with this symbol. So E for electrons, and we always use the negative at the top like that. But we don't just say plus electrons. We want to be specific. If there's three electrons, we'll put a three in front. If it's one electron, we won't show anything. If it's 10 electrons, 10 at the front. So we always want to show the number of electrons. So either it's going to be gained or lost. Okay, so those are the two general rules of how we write this. And then the last part, I think this will make it very easy for you to remember. Because remember, let's just quickly look at this example last week. I'll give you some time to take it down when you're done. But if we looked at this example, let's just quickly look at the highlighted bit. This is an example of a half reaction. Our goal is to write it out like this. Now, depending on whether it's oxidation, you can see in yellow, we've got the electrons on the, I'm going to call this the product side, okay, the right-hand side. If it's a reduction reaction, you see it's different. We've got the electrons on the reactant side, on the left-hand side. Okay, so I made a little rule of how you can remember this, and I think it'll be easier because it's easy to forget, right? If you're in your exam, you might forget, do I write the electrons on the right side or left side? So I made a little thing where you can remember. If it's a oxidation reaction, okay, then you always show your electrons on the product side. So let me just quickly show you what this means. So if you ever have a chemical reaction, let's see like this. We know that we've got a reactant side, which is all the inputs that you're putting in, right? The products you start, sorry, the substances you start in with. So this is always on the left-hand side. And then when we draw our arrow on the right-hand side, we always have our products. Okay, that's very basic. So when you have an oxidation reaction, you always want to show the electrons on the product side. I'm going to write electrons like this for short. Electrons on the product side. So how do we know this? If you look at oxidation, the word oxidation, it's got an O in it. Product side has an O in it. So this will tell us if we have the oxidation half reaction, then we need to say electrons on the product side. And then for reduction, we show the electrons on the reactant side. And how would we know this? Well, you can already guess. If we look at reduction, the word reduction has an R, reactant has an R, so this will tell us it needs to be on the reactant side. So here's the reactant side, and here is the product side. So it is a little bit of a step to remember, but if you learn this often, you will never ever make a mistake on where you show it. And remember, if you're writing it in the wrong side, then they won't give you a mark for that because it's an incorrect equation. So make sure you actually go through this. It's an easy way of remembering, so that sorts your problem out with that. So let's just quickly look at the example to demonstrate this. We looked at the one with magnesium, oxygen giving us magnesium oxide. And let's pretend that this was the exam and we just saw that this equation now is on the question. And let's say the question is asking us which is the oxidation substance, which is the reduction substance, which is your oxidizing agent, which is your reduction agent, and write down your half reactions. So we want to go through all of those things. We're given the simple equation. Let's go through the steps of where we would start. So step one, if we go back to our basic steps here, we would want to find the oxidation number of each element in the given equation. So if we're looking at this equation, our first step is to get the oxidation number of each substance. Let's start off with magnesium. This is a pure element, back to our rules. So we put a 0 at the top. Same with oxygen. And now magnesium oxide. This is a compound, right? Let's not forget the rules. I'm going to write it down on the side here. This is a compound, which means, what do we know about compounds? Their oxidation number, if you add both of it, must give us 0. Okay, so if we've got magnesium oxide, we look on the periodic table. What is our oxidation number of oxygen? So if you go to your periodic table, your oxidation number of oxygen would be -2. So what is magnesium? If magnesium plus this -2 must give me 0, I know that that number should always be a +2. So from here we can say that this is a +2. So now let's write it down on our equation. This is -2, this is +2. Okay, so we've identified the oxidation number for each element in the chemical equation. The next thing we're going to do is we're going to see how is that number changing. Okay, so we're going to do this quickly since we've done this example. If we look at magnesium, the oxidation number is going from 0 to +2. Is this an increase or a decrease in the oxidation number? This is an increase in your oxidation number, right? Or another way of saying it is it losing electrons or gaining electrons? It has to lose electrons because this number is becoming more positive. So we can say there's a loss of electrons. And if there's a loss of electrons, what type of reaction is this? Oxidation or reduction? Oxidation. How do we know that? Because a loss means oxidation. Okay, same thing for oxygen. The number is going from 0 to -2. So this is becoming more negative. So is it gaining electrons? Yes. And this therefore must be reduction. So if you were to answer the question, which is the oxidizing agent and which is the reducing agent, we can immediately tell because we know what reaction is taking place. So we can tell that magnesium has to be the reducing agent because it's undergoing reduction. Sorry, it's undergoing oxidation. And we can tell that oxygen must be the oxidizing agent. Okay, I know we're repeating this example, but we're just going through the steps again to refresh your memories. The next thing now is how would we write down those half reactions? So let's use our new rules that we've got here to do that. So if we want to, let's start with oxidation since that's number 1 on our list. For an oxidation reaction, to show the half reaction, we want to show the electrons on the product side. Okay, so what we would say is magnesium is becoming magnesium +2, and how many electrons did it lose? It lost 2 electrons. So how did we get 2 electrons? This came from the number, right? We went from 0 to +2. This must mean it lost 2 electrons. So to get the number, you're going to look at what is the change in oxidation number, and we'll do more examples with this. But this would be the basic example of how we write down magnesium. Remember, why am I not putting a 0 here? Because the rule is when we're doing half reactions, we don't show it if it's 0. And then if we're showing the next one, which is reduction, I'm looking at this rule here. What we're going to say is that oxygen is losing 2 electrons. Sorry, it's gaining, right? On the reactant side, that's why I'm drawing it before the arrow. And this is giving us O2 minus, or minus 2. So we're going to have to be able to do these half reactions for much more complicated examples, but we'll work our way up. This is the basic theory for today, and we're going to look at this. Okay, so let's look at another example. Okay, so we're given another equation where we have zinc, hydrochloric acid, and this is giving us H2 plus. Okay, so what we're going to do is we're going to work through it, and I'm going to make sure you're going to do most of this yourself. We're just going to mark it. But the first thing we'll do is I want you to write down the oxidation number at the top of every substance, and then we'll mark that just so that everybody has that right, and then we'll move on to the actual reactions. So the first step is just write down the oxidation number above every element. Okay, let's continue now doing this. So the first element we have is zinc, and zinc we can just say is a pure element. It's on its own, so its oxidation number is going to be 0. So using a different color on the top, I'm going to put a 0. Same with hydrogen gas, okay? It's by itself, it's a pure element, so it's going to be 0. If you look at hydrochloric acid, HCl, those are two different elements coming together. So this is classified as a compound. Let's just write it here. And same with this, right? It's a compound, which means you're going to have to go and do a little bit of work to find out what is its oxidation number. So I'm going to do it on the side here. Let's start with HCl. Okay, if we look at our periodic table, we're looking for chlorine. We always start off with the one on the right-hand side. So if we look for chlorine, remember our rules from our periodic table. I'm just going to write it here. This is 0, -1, -2, and so forth. So chlorine is going to be -1. Okay, so this is -1. We know if we add both numbers, so whatever that is, it must give us 0, okay? Because it's a compound, a neutral compound. So that unknown is going to be +1. So we can therefore write down, we've got -1 and +1. Okay, then let's look at zinc and chlorine gas. Okay, and remember now you've got 2 chlorine elements here. So same thing, we're going to look for chlorine. From our periodic table, we know chlorine is a -1. And we don't know what zinc is, but if we add both, we must get 0. So let's just be careful of how we're doing this one. We've got an unknown plus. Now remember, we wouldn't just say -1 because we've got 2 chlorine atoms. So we're going to put a 2 here, -1, giving us 0. Okay, just be careful when you have this diatomic elements. Okay, so if we do this, we would have plus, this will be a -2 equal to 0. So our unknown must be +2. Okay, so if we're looking at writing it down, we have a A minus 2 and a plus 2. Okay, so the next thing we're going to do is I want you guys to find out, or at least write down, which reaction is undergoing, or which substance rather is undergoing oxidation, and which substance is undergoing reduction. And also write down the reducing agent and oxidizing agent. So the first thing we're going to do is we're going to look at which substances we have. So let's see, we've got zinc, hydrogen, and chlorine. Let's highlight them individually. So we've got zinc here. Zinc is going from 0 there to plus 2 here. We've got hydrogen here, and then we also have chlorine, okay? But we're going to just look at chlorine here. Okay. So what we're going to notice here is, let's write down zinc first. Zinc, we can see the numbers changing from 0 to positive 2. So that oxidation number is increasing. And if the oxidation number is increasing, it means it's losing electrons. There's a loss of electrons. Therefore, zinc must be undergoing oxidation. Okay, and this must also mean that zinc is our reducing agent. And then if we look at HCl, hydrogen, the number is going from plus 1 to 0, so that's technically decreasing. And if you look at chlorine, it's going from negative 1 to negative 2, so it's also decreasing. Okay, so we're going to write it just as chlorine for now, okay? So we're going to say chlorine is going from negative 1 to negative 2. And we've got a gain of electrons. So this is undergoing reduction. And this must be our oxidizing agent. Okay. So we're not going to do the half reactions just yet because I'm going to give you more of the exam type ones. But if we were to write a half reaction, let's just take zinc for an example. If we're looking at zinc and we wanted to write its half reaction, and let's remember quickly with our rules, okay? So the rule is now the first thing you want to ask yourself is all of the other information is given to you in the actual question, right? So the only thing you need to figure out is how many electrons is it losing? So that's the first question. How many electrons is zinc losing? And from that, you look at the oxidation number. So the oxidation number is going from 0 to positive 2. And this must mean that it's lost 2 electrons, right? If you're going to jump, if you look at the number line, If we want to jump from 0, we first have to lose 1 electron, 2 electrons, right? To get to positive 2. So you can think of it in that way. So our answer here would be 2 electrons. And then we need to figure out which side of the reaction are we writing this. So remember, we've got our O in oxidation. This is our oxidation half reaction, which means it's going to go on the product side because of the O in product. Product side in other words, after the arrow, okay, here. So how would that look? So we would say zinc is going to become zinc. And remember, I'm looking at the numbers from the question here. 2 plus, because it lost 2 electrons. Notice it's on the product side after the arrow. So that's what your half reaction would look like. So it's not too bad, it's not too complicated. It's just I want you guys to get used to identifying firstly which is your oxidizing and reducing reactions and substances. So we're going to do a few more examples like this. Okay, so I'm going to give you a few examples where it gets a little bit more complicated with more substances, just to make sure you still know your rules. Okay, so here we're going from, now remember that some of the examples you're going to get here is going to be special ions, so just make sure you look for that. And remember as well with these reactions, it doesn't matter whether it's balanced or not. We'll actually get to the part at the end where we start balancing using the half reaction. But for now, we're not worried if it's balanced or not. We'll see actually, if it's not balanced, we're going to start using the half reactions to balance the equation. So I'm just going to leave out the subscripts here, coefficient. Okay, so given this reaction, we want to do the exact same thing now. So write down which substance is undergoing oxidation, which one's undergoing reduction, and how many electrons is it losing or gaining. We've got an unknown for carbon plus. Now remember again, be careful, you've got a 2 there. 2 into minus 2 giving me 0. If we simplify this, we have minus 4 here equal to 0. So the unknown must be positive 4. So carbon is plus 4 and oxygen is minus 2. And the last one we've got is H2O. Again, in our periodic table, we know that oxygen is negative 2. We don't know what hydrogen is in this case. So we're going to put an unknown plus. Now remember, we have to be a little bit clever in how you're doing this one, right? We're putting a question mark, but we know we've got 2 of these hydrogen molecules. So we're going to have 2 of those question marks plus a negative 2 equal to 0. Now remember that this question mark is nothing more than just an unknown, so I can even call it an x. So we're dealing with just a very simple equation like this. If we solve this equation, we'll have 2x is equal to positive 2. And if we divide, we'll get that x is equal to plus 1. Okay, so we've got a plus 1 and a minus 2. So these are our oxidation numbers that we're sitting with. Let's look at how they're changing. So if we look at carbon, carbon is going from a minus 4 here to a positive 4. Hydrogen, and this is a good example to show this, hydrogen's number is not changing, right? It's got plus 1 on the reactant side and it's +1 on the product side. So that number really hasn't changed, so it didn't undergo oxidation or reduction. If we look at oxygen, it was 0 and it changed to -2 on both sides. Okay, so we can clearly see which substances numbers are changing. Let's write it down. If we look at carbon first. So for carbon, our number is going from a -4 to +4. Okay, let's just write down both and then we'll analyze. And then for oxygen, the number for the oxidation is going from 0 to -2. So always when we're dealing with these examples, you want to get to this point and then you can ask yourself, is there a loss or gain of electrons? Let's look at carbon. We're going from being -4 to being +4. So that's a big jump. That's going from the negative side to positive side. So that means we must have lost electrons. And because there's a loss of electrons, this would be regarded as our oxidation reaction. Okay, so oxidation reaction, and we can say that carbon is now the reducing agent. And then for oxygen, let's actually first look at how many electrons did carbon lose. How would we get that number? We need to look at the oxidation number, right? We're going from -4 to +4. So a little bit of thinking, a little bit of maths. If you are -4 on the number line and you end up all the way to +4, how many steps would you have to have taken to get to +4? So remember 0 is here, so you would have to take 4 steps here first to get to 0 and then another 4 to get to +4. So then a total of 8 electrons that you lost. So it would have lost 8 electrons. And then the next one, if we look at oxygen, this is going from being 0 to -2. Okay, so in this case, this would have gained electrons. And a gain of electron, why? Because we're getting more negative, okay? If we look at the number line, we are going backwards now, right? We're going all the way to the negative side. So we gained electrons. This must therefore be our reduction substance and our oxidizing agent. Oxidizing agent, and again we can ask ourselves a question, how many electrons did oxygen gain? This one is a bit simple. If we're on 0 here on the number line, we would need to jump twice to get to -2. So we would have gained 2 electrons. Okay, so just basically becoming very familiar with these types of equations. Got about 7 minutes, so I think let's just go through well, let me just quickly show you an exam type question. Okay, so I have one here. I didn't copy the entire question, so I'll go back and do that. I don't think we'll do this today, just to kind of show you how they test this in an exam. Here you're given a balanced equation. Okay, so you can see these equations are a lot more going on. You've got a lot of substances in here, definitely more than like 3 substances. And then the first question here, 10.5, is they're asking you specifically for zinc. They're saying, does zinc undergo oxidation or reduction during this precipitation reaction? So you would have to do a quick calculation by looking at your oxidation numbers in this equation and figure out, is it a oxidation or a reduction reaction? So I think let's actually answer it. We can actually do that. So I'll give you some time to try it on your own. Remember, all you have to do is write down the oxidation numbers above, and then you can figure out if it's oxidation or reduction. And then 10.6 as well, for 2 marks, they want you to write down a half reaction. So let's say like 3 minutes to try this, and then we'll do the answer. Question. Next lesson, we'll talk about why this is a +2. If there's any other questions, you can ask. You can stay back and ask now. If not, I'll see you guys tomorrow.